So here's a typical hormone cascade. We have CRH, ACTH, and cortisol. Now, we talked about, so this is saying how to make a hormone signal once you initiate it, how to make it stronger and stronger. But remember that in the examples of growth hormone and prolactin, that you can't have high levels of hormone all the time. You kind of need hormones when you need it, but how do you turn this whole thing off? So we talked about how to turn hormones on, but do hormones stay on the whole time? No, they don't. So how do you turn this whole system off? And this is how you turn it off. So notice what we here this is what we covered in the previous lectures, how you stimulate and cause these hormone cascades. But now this is how you how you press the brakes on this whole system. And this is how you turn it off. And it involves something called negative feedback. So what is feedback? Well, feedback is when a hormone affects its own production or activity. There's two major ways of feedback. You have positive feedback and negative feedback. So positive feedback is when a hormone kind of amplifies itself. Whereas negative feedback, you have these hormones being kept in a sort, and actually most of your hormones have negative feedback as some way of controlling a normal level where it's not too high and not too low. It kind of helps to keep a normal range. So negative feedback, let's cover that first. So what is negative feedback? So what we have here, so hormone A, now this is an example where I'm just talking about hormones. But it can also be stimulate, or actually I'll get to it soon. So what we have here in this example, hormone A is causing the production of hormone B. But hormone B is going to turn off the production of hormone A. So yeah, it's not doing it in kind. So it's like what we have, A triggers B, but B inhibits A. So this is what we see in many of these hormones and stimuli. So it's not necessarily just hormones. Like you can also have a stimulus causing the release of a hormone, but that hormone reducing that stimulus. So it can be a mixture of stimuli and hormones, or hormones and other hormones. But what we have here, A turns on B, but B turns off A. And this is what we see. And we see multiple instances of this kind of like feedback loop in the human body. Now, I like to use this example. I know it sounds very theoretical. So this is an example of negative feedback. So here's this little box. And if you were here last semester, you're seeing this box. So what you have is like somebody's turning on this box. This causes things in the box to change. And this little hand comes out and turns off its box. So the interesting thing is that here we have like a stimulus, right? So this stimulus A is causing all the little internal machinery of this box to extend this arm. But what does this arm do? This arm ends up flicking itself back off, thereby returning the box to its off and closed state. So the box is being disturbed, but due to this negative feedback mechanisms that are activated when you disturb it, it turns itself off. So you see this all the time in these negative feedback loops. Now, how does that control hormone levels? Well, again, in this example, I'm talking about two theoretical hormones, or like two general examples of hormones. So what we have here is hormone A accumulating. So remember, in this example, we have hormone A triggering the production of hormone B. If you have more hormone A, you're going to have more of hormone B. But as you have more hormone B, that starts to apply the brakes to the production of hormone A. Remember, like A is turning on B in this example, but B is turning off A. So as you apply the brakes harder to A, what happens is that A starts to drop off. As the hormone is starting to clear and degrade from the body, then it starts to lower the concentration of A. But when you have lowered the concentration of A, you also lower the concentration of B. So B is going to now drop off as well in concentration. But as B decreases, now the brakes ease up. Now we have the brakes easing up on A. A is free to accumulate again. So what we saw here is that A was increasing, then dropped off, and now it can increase again. So in hormones that are controlled by negative feedback loops, we often see this kind of cyclical up and down pattern as we see here. But what is it trying to do? It's trying to prevent hormone A from accumulating too much where it's out of control. It has to bring it down back to normal levels eventually. Now, ACTH and cortisol, this is a classic example of a feedback loop. So what we have here is the pituitary releasing ACTH. and this triggers the adrenal cortex to produce cortisol. But cortisol also has effects. I mean, it has many effects, one of which is that the cortisol also targets the pituitary. But it targets the pituitary and tells the pituitary to shut off ACTH. So ACTH is no longer being now lower levels of ACTH are being produced. But if you have a lack of ACTH, can the adrenal cortex really produce cortisol? Not really, right? It's not getting the signal. So cortisol is going to drop off, and then the whole cycle can start over again. So this is what prevents cortisol from accumulating, what prevents in the normal functioning body, it prevents too much cortisol from being produced. If you produce too much cortisol, it applies the brakes on the pituitary and applies the brakes on the ACTH. So this is why you see all these like changes in cortisol. As you notice here, like the dark triangles are ACTH. Every time you have an increase in ACTH, notice that there is an increase in cortisol. But every time you have an increase in cortisol, that triggers a drop in ACTH. So this up down pattern is all due to this kind of negative feedback system. And there are multiple examples of this in the body. Now let's talk about positive feedback. So positive feedback, instead of A turning on B and B turning off A, now we have A and B kind of feeding off of each other. So this is relatively rare in the human body because what happens is that you have a hormone amplifying itself until something big happens. And what happens is like hormone is instead of like one turning on other and the other turning the other off, in A we have it turning on B, but B is going to stimulate production of more A. So what we see is that as you produce more A, you produce more B. As you produce more B, you produce more A. So there's no real breaks mechanism here. So what we have here is kind of spiraling and have these more A, more B, more A, more B. And then something shuts it off. And so the thing is that it typically ends with some major event that shuts off the production of A or B. So I often get this question, what's the difference between negative feedback and positive feedback if you have a major event ending the positive feedback cycle? Well, the interesting thing is that kind of when you have negative feedback, it's more of a gradual thing, whereas positive feedback, when you have that event that ends this kind of like spiraling cycle, it's typically something external to this system, not one of these hormones. And then it just like, it's very sudden, a very big drop in these hormones versus a gradual applying the brake and negative feedback. So example of this is the Ferguson reflex. This is a little complex, but it's a good example of this positive feedback. So instead of the two hormones, what we have here is a stimulus and a hormone. Yep. So what we have here is the uterus and cervix. So yeah, she's getting her first contractions. So now we have this baby pushing on the cervix right here and this part of the uterus. So this is going to send signals up to the posterior pituitary. And this is what causes it. So what it's going to do is trigger the secretion of oxytocin. Now oxytocin, what it does is that it also targets the uterus and cervix. So what it's going to do is cause increased uterine contractions. So if you contract the tissue, what is it going to do to the pressure inside the tissue? So if you have your hand and you have your fist and you contract your hand, it's going to cause more pressure on your fist, right? So that's what happens in uterine contraction. It causes more pressure on the inside. As you apply more pressure, what does that do to the baby's pressure and the cervix? Well, that's going to cause more cervical pressure. As you do more cervical pressure, that's going to cause the release of more oxytocin. As you release more oxytocin, this pressure increases. So this is why in labor, why you don't see like a negative feedback mechanism. As you get that first contractions, what happens? These contractions get not only do they get stronger, they also get more frequent. So this is an example of positive feedback. But do these contractions last for this woman's entire life? No, right? That would be hell for her, right? So these contractions increase in amplitude and frequency, but what's the major event? Well, what we have here, if you increase the contractions and keep on increasing the pressure, and the uterus is trying to squeeze this new baby out, eventually it's going to get pushed out. And when you have this baby, now you have this big object being released from your uterus, and do you have that pressure anymore? Yeah, it's a big release of pressure. So what happens is that oxytocin drops off, and then as oxytocin drops off, you don't have the contractions. So that's the major event that breaks that loop. Yep, so then contractions are pleasurable. Oh, you should ask someone who's given birth. Okay, aren't pleasurable. Yeah, so that's why the love hormone thing is kind of like it's kind of like marketing. Like I think the people who research this, they're kind of marketing it as a love hormone to kind of make it like, oh, this is very appealing and very interesting. But as we see here, it's also has other effects as well. Yeah, so again, the love hormone part, that's marketing, and I think people are trying to make oxytocin research kind of appealing. So again, oxytocin does many things. This is another example of it.